Now it is time to have some fun and learn more about using task analytic instruction to teach inquiry as a process to learn science content. This is a chart developed by the National Research Council as part of the National Science Education Standards Teaching Guide. Look at the first column on the left. Listed down that column are the essential features of inquiry. The next four columns take each of the essential features and describe variations that can be used to teach inquiry, beginning with more self-directed learning to more teacher-directed learning on the right. Many students with significant intellectual disabilities will access the essential features of inquiry through the variations listed in the last two columns. Take a minute before clicking on the next slide to look at how the essential features change in delivery and student responses from the second column to the last column. One strategy when planning inquiry science instruction for students with significant intellectual disabilities is to remember what strong instructional alignment is. For more information or to review, you can visit the MAST module on instructional alignment. One of the 8 criteria for instructional alignment involves grade level differentiation. While the content in science will grow in breadth and depth, it also is important to help students strengthen the process of inquiry as a skill in of itself. In the next several slides, we'll discuss each step of the task analysis for teaching inquiry. You will see a variation for each grade band. Each step on the task analysis that we will look at will be provided in 3 different colors: blue for elementary, pink for math, and green for high school. Not all students in high school will be able to complete each step at the self-directed level. However, instruction in science should focus on building students' skills throughout the years, providing more opportunity for self-directed learning. Let's look at the first step in the next slide. The first step of inquiry science task analysis is to introduce the lesson. In the PowerPoint you have already watched, you have learned about the use of wonder stories to provide students with the context to learn new information. That is step 1 of the task analysis. Step 2 is to review the target vocabulary from the lesson. Remember that students may learn vocabulary in different formats, depending on the symbolic level in which they access the curriculum. You'll notice that each box for step 2, review target vocabulary, gives the learner the options of using words, pictures, or maybe objects to respond. This may take extra planning for students who access the curriculum at a pre-symbolic level, or may understand abstract concepts, but they may have a visual impairment. For more information on symbolic levels, you can also refer to the module on instructional alignment or story-based lessons. Next, step 3 gives students an opportunity to touch the materials that will be used in the lesson, or maybe ask questions, or it allows the students to report out what they already know about the materials. In elementary school, this may be used as a means to introduce communication skills, or the ability for students to indicate a yes/no response. Let's also take a look at a sample of target vocabulary from a sample lesson. This is an example of target vocabulary for 2 separate lessons. As you can see, the vocabulary is adapted with picture symbols. One strategy when teaching vocabulary is to teach the students to identify the word, picture symbol, and maybe an object that matches the concept. To review the target vocabulary, you can also use time delay. You'll be able to watch a video later in this module of a teacher using time delay in a science lesson, so look forward to that. Here is a KWHL chart from the curriculum Teaching to the Standards in Science, published by Attainment Company. You'll notice that there are 4 boxes that the teacher or students fill in as they progress through the science inquiry lesson. There's also an area at the bottom for the student's name and whatever prediction they may have later. So, using this chart, the first box is what do we know, the second is what do we want to know, then how will we find out, and finally what do we learn. Throughout this module, we'll refer to this chart as a KWHL chart. So using the KWHL chart, step 4 of the task analysis asks the students and or the teacher to fill in the K of the chart for what they know about the materials. Using the materials that were introduced at the beginning of the lesson, the teacher will hold up one material at a time and ask the students what they know about it. For example, in a unit about the rock cycle, a teacher may hold up a rock and ask students what do they know about it. A student may respond, it's hard, or it's brown, or it comes from the dirt. While students may be able to generate some verbal responses, it may also be necessary to create a response board for other students, or they could use assistive technology devices to respond. The next step is step 5 of the task analysis. During this step, the teacher will ask the students to identify what they would like to find out during the lesson. Some students may be able to generate a response, while others again may need a response board. The Wonder Story is a great way to provide students with an option of what they could respond. For example, at the end of the story we looked at earlier in this module with the Wonder Story PowerPoint, the student might respond, I want to know, does the moon change shapes? The 6th step of the task analysis involves the KWHL chart. Students generate a response in step 5 and record it in step 6. Do you see how the KWHL chart is used differently in elementary school, middle school, and high school? The next step of the task analysis is to make a prediction. This is a very important step of the task analysis. The main idea of inquiry is for students to pose questions, discover, and report answers to those questions. The prediction is one of the steps of the task analysis that all students should participate in every time the lesson is taught. Remember, students may not be able to generate an answer verbally, or not all students. Like all steps in the task analysis, it's important to make sure that all students are given a way to respond. Students may answer a question by responding yes or no, verbally, through eye gaze, smiling to indicate yes, or maybe through augmentative communication. Step 8 is used to allow students a chance to touch or feel the materials, to investigate. If the materials are not safe for them to touch, you may be able to have them look at them, stir them, or just observe what the materials are currently doing. Step 9 involves the KWHL chart again. Students will be asked to identify how they will find out the information. Always wait a few seconds to allow students to generate their own responses. Guide students to make a choice from several options as needed. This could be through a response board with picture symbols, asking the students to eye gaze between a hammer or a spoon for a chemistry lesson on chemical reactions, and looking at the spoon as the correct response, where a hammer could be your discrimination object. For each step in the task analysis that involves the KWHL chart, in elementary level grades, the teacher will usually have the chart in the classroom posted, and the teacher will record the information as the class generates responses. By middle school, though, students may have their own chart in which they record their responses, and maybe do that within a cooperative learning group. Finally, in high school, students can self-direct their inquiry learning by filling in the information on their own chart without the teacher telling them when. So when the teacher asks the question, they fill in the information via writing it, placing picture symbols in the boxes of the chart, or maybe peer records the answers for them. Finally, to the fun part, the experiment. This portion of the lesson is usually hands-on, meaning that the teacher and the students conduct the experiment. Sometimes it's just a concept that a typical experiment doesn't work for, but that's okay. Maybe making a model of the Earth's layer is the experiment, or watching a short video about earthquakes may be something that would work for an activity or experiment. Just remember when planning your lessons that students love to wonder. They love to wonder and ask questions. The experiments allow them a hands-on, multi-sensory approach to pose and answer questions. Check out grade-level science textbooks in the grades that you teach, and talk to general education science teachers. They both have great ideas for experiments. For step 11, read the concept statement. The big idea of the lesson is the concept statement. We'll look at an example on the next slide. The concept statement is one main idea or the big picture of the lesson that you want all students to master. For example, in a lesson where students have a piece of clay and different animals, maybe toys, of course, they may walk on the clay without the students actually seeing, and then the students learn about fossils and imprints and how even though they didn't see the animal walk on it, they could tell what fossil or who walked on the fossil to make that imprint by maybe the footprint. The big idea of this concept, or the concept statement, may be fossils are imprints that tell us about the past. The main idea is not about dinosaurs or the footprint, it's about the concept. Next, in Step 12. Step 12 involves recording what the students learned in the lesson, so they put that concept statement into the L on the chart. Here are two examples of concept statements. You can see that they're all adapted with picture symbols. Students may be able to match the concept statement with the actual materials in the story to build some symbolic understanding. For example, in the concept statement involving solutions, it may be necessary to match the solute, which could be Kool-Aid, with the solvent, which could be water, to the solution, maybe a red-colored drink. Step 13 involves reviewing the actual experiment. While the concept statement addresses the big idea of the lesson, it's important to review the prediction the students made at the beginning of the lesson, then come back to it again in Step 13 and see if they were correct. Students can either say, yes, I was correct, or no, I wasn't, or they may be able to change their answer if needed from an array of maybe 3 choices. Remember to always give students time to generate their own responses if they're able. Finally, students should be given an opportunity to complete a fill-in-the-blank of the concept statement. So, for the example from the previous slide, blank are imprints that tell us about the past, so the answer would be fossils. This may be represented on a smartboard, paper and pencil, fill in the blank with maybe some picture symbols or objects, or even with a laminated concept statement and Velcro for the fill-in portion. Remember, all students should be given an opportunity to use the response mode that they currently have, which could be grasping something, pointing, eye gaze, verbal response, using a head switch to show you what they know. Here are 2 examples of concept summarizations, where students can show what they know and understand by filling in the big idea of the concept statement. Another great way to measure comprehension would be to ask students to match the materials, maybe a fossil, to the concept statement from an array of 3 or 4 materials. Look at these 2 concept statements on this page. Now let's return to the module to watch videos that demonstrate some of the steps of the task analysis we've just learned about.
Actually, before we go back to your module, let's take just a minute to link the 14-step task analysis to the next generation science standards. The K-12 framework helps us think about what inquiry science really is and how students are able to build their fluency within science education. This diagram you see here outlines science learning within engagement, investigation, and description, explanations, and reporting. The reasons that some of the components in each of the 4 areas are in bold is that these are new additions to the 2013 science standards. Emphasis is needed in our teaching that highlights how students and their ability to ask these questions, ask science questions, rather than only respond to those of their teachers. Think about the relationship to the step of the task analysis, such as the wonder stories, and how students will be able to build upon these steps and this skill over the years. Within the next box, you see plan and carry out investigations. Again, let's relate this back to the task analysis we just reviewed. Think about how this relates to the step of the KWHL chart for H. How will you learn? Or how will you learn more? Or how are you going to find out your answer? Next, let's go to the next box for explain. Within there, you see analyze and interpret data and communicate information within reporting. Again, think back to your task analysis. How are we addressing these needs for our students? Think about within the final steps of the task analysis, where students start to summarize what they've learned, review the results of their experiment. We're linking this back to interpreting data and communicating information. All students can participate in all of these steps of the inquiry process and inquiry learning with meaningful modifications and thoughtful consideration of what science really is. Now, I think we're ready to return to our module.